Hello, I am that Rob Human again. This is part 3 of my series. I said it before, I'll say it again. I don't script these, so I'm sitting here and talking for a bit. You might get rambling, or like in the last video, I might get a text message and whatnot. So it's all very off the cuff. In this episode, we're going to talk about custom nodes and subgraphs, which is a way to bundle a bunch of nodes together that behave in a certain way that you want, and you get to expose certain inputs and outputs as you choose instead of having a whole grand list of things. The best way to do this is probably to just kind of make one. So I'm going to come down here and click on custom, and it brings up a whole new interface. Similar to the main graph, but there's a nice blue background of the Cartesian grid just to signify this is different. I can set the name of my custom node, and you can actually see it down here grayed out because you can't do recursive references. And we got this bar on the left, which we'll get to in a minute. And the drawer is pretty much the same, except there's a couple more categories of inputs and outputs, new nodes, that are specifically for subgraphs. And we'll get to those in a second. But yeah, we can actually just go ahead and start building our subgraph. So I know that I want to have this node have a shape output. And these inputs and outputs are basically how the node gets interacted with on the outside. So this will be shape output. And I know I actually want a path as well, so I'm just going to throw that in there and we'll come back to it. And I know I want a couple inputs, but I'm going to hold off on those. I think it's easier for me to build this from outputs towards inputs. So I know I'm going to want a layer with at least 3 layers here. And we'll get to why in a minute. And I know I want a couple different circles. Cool. In fact, I want 3. I know I'll need 3. And I'm actually going to set up a preview just so I can see what is going on as I combine everything together. So, yeah. Well, actually, I'm going to be working more down here, so we'll do that. What I'm going to build here is a planetary system glyph looking thing, just for celestial reasons. So this is going to be my orbit. This is going to be my planet. And this is going to be my star circle. You'll see why I'm naming that specially in a minute. Okay, so I'm going to set some default things here. For one, I definitely want to have the fill turned off there. Cool. I definitely want to turn off the stroke here. And I definitely want to turn off the stroke here. Okay. Yeah. So let's start getting into the inputs. Now, I know I want to do... Oh, not a layers. A length input. This is going to be my orbit radius. So on most of these inputs, you're going to have a couple parameters. For one, you can choose whether or not it has a socket. So like you could actually turn off an input socket if you just want to give them the widget. I'm going to leave these turned on. Most inputs have a widget that you can choose. You can say none if you don't want any, no type in values. Some have a couple other variations, but most of them just have input. You can set an initial value, and this is both what gets parsed while you're previewing it in this subgraph pop-up, but also when you create a new custom node, this is what the value is to begin with, hence initial. And you can set like a maximum and a minimum. I always set a minimum of 0 pixels on my lengths because a negative length doesn't actually make a lot of sense. You can do steps and snaps. Step is basically, on most inputs, you can actually hit the up arrow or down arrow to increment it. So you can dictate how big that stepping is. And snapping is essentially if you want to have an input adhere to a certain factor. So like you could type in 3 pixels, meaning it has to be a multiple of 3 pixels, for example. I don't use them very often, but the option's there. All right, so I've got my orbit radius, and I'm going to actually plug this into the orbit. I'm going to just wire this up here. You'll see the preview comes up. Cool. And I'm going to do the same thing on the planet, except I'm going to change the transform to polar. This is the polar radius. Cool. We can wire that up. Oh, that's not supposed to do that. And let's actually do that. I gotta fix that. That's a bug. Anyways, so we got a radius of 10 here, and I'm actually gonna set the fill color to black. There we go. Okay, so now you can actually see the planet. Good, good. So I'm going to need another input, and we're going to call this revolution. And we're going to change this to a slider, because I know that's going to be a thing. And we'll wrap the value from 0 to 360. And this is going to get plugged into the position theta of our planet. So now, as I set the initial value, you'll see that it rotates around. Cool. So that's revolution, and that's the orbit radius. Cool. Let's get a orbit color in here. We'll set an initial value of black, and this is just going to go into the stroke here. And orbit color, we'll need an orbit thickness as well. I will just call it orbit stroke. The initial value of 1 pixel, minimum 0 pixel, and we can just wire this up to the stroke width. Cool. So we change that. That makes the orbit thicker. We're going to circle back to the orbit in a minute, because I have another thought there, but we'll do that first. Let's get another length input, and this is going to be a planet radius. And 10 is a good initial, so we'll do that. Minimum of 0, and we'll just chuck that in the radius. So now we can control the radius of the planet from here. Neat. Probably need a planet color, which I'm going to do independently of the orbit color as well. We can set a default of black as the same here, and we'll just plug that into the fill color. Cool. So now we can be like, give me red. Awesome. Just to make sure that works. And then the next one is the star. And you know, I could just do this the circle again, but let's get a little bit fancy. Let's play with this a little bit here. I'm gonna do a couple variations on this. We're gonna have our star circle. Let's do 20. I'm gonna say 20. And we'll come back to the star in a second. So what I'm thinking here is if we actually give this an enum input, and we'll give this star style, we're going to have 3 options. We're going to say circle, diamond, and star. And we're going to change the widget to be a vertical radio button, because I like how those look. And then we're going to take some logic, do a switch case. We'll wire up the enum to the switch, and give us another case here, and we'll say star circle. We'll do the diamond there, and then we'll do the star here. And then we'll pipe this whole thing into the 3rd layer. What am I missing? Planet radius. No, that's right. No? Oh, right, I need to actually put in a star color. Let's do that. Color input. Let's do star color. Set it to a default of black. We'll just plug this into the fill. Set this to none. That's the polygon. Cool. We'll do the same thing here. Fill. Good. Okay, now that shows up. And we'll do the same thing here. We want no stroke. We want to wire up the star color to the fill color. So now, if I change our star style, we can go circle, or diamond, or star. Oh, that's not right. And that is because this planet, I have not wired up a length input for star radius. Would help if I could spell correctly. Okay, initial value we'll say 10, minimum 0. Cool. Let's get that out of the way. Now on this one, I'm going to just wire this up to, not points, to the radius. And we'll wire this up to the radius. And then we'll wire this up to the outer radius. And we're actually going to set this to 4. Now, I know that a good sized star, a 4-pointed star, let's do 10. Yeah, that looks good. A good 4-pointed star, you want the inner radius to be about 25% of the outer radius. That usually looks pretty good. So we're actually going to use a math node here. And we're going to say, where's it, multiply. We're going to take the star radius and then take a primitive of a length, nope, sorry, of a float, multiply it by, let's actually go for a third instead of 25%. Cool, and then we can pop this into the inner radius. And there we go. We can just leave those there. That's fine. So we have our star, and now we can swap around depending on what these are. Cool. Now, one thing is that the circle and the diamond have a much more powerful presence than the star, and this is where the different scribe modes come in handy. So I'm definitely going to leave the star circle as is because I can't change it, clearly. But I'm going to change this polygon to use the middle scribe. And so now the circle and the diamond have a bit more of the same visual weight, so to speak. And the star, well, that's easy. I'm probably going to set this to circumscribe on both of these. And that's probably going to look, yeah, see, that looks good. I might actually change this to 0.4. Nah. Yeah, okay, 3.5. That's good. So yeah, that's our star. Now, I did have a thought here earlier, and I'm going to play with it. And this is where some of the math nodes come in handy. I'm going to take this orbit here, and I'm actually going to split this off a little bit. And we're going to do, where is it? I want to do a shape. Let's do a ring, okay? And I'm going to change this to spread mode. Orbit radius of this, so that's this. And we're actually going to do another input of a length, and we're going to call this orbit gap. Minimum of 0 pixels, as always. And we're going to wire this up to the spread. Now, I could get away with just plugging the ring into this, and that should be fine, but technically speaking, if I do that, there will be two circles that overlap each other, so you'll get the stroke twice, which is not that big of a deal. However, if you're working with like different opacities, it'll end up more opaque than it is expected. So what we're actually going to do here is use a combination of the ring or the orbit, depending on this orbit gap value. So we're going to do a little bit of logic and say if the orbit gap is greater than, no, we want actually, sorry, less than or equal to, if the orbit gap is less than or equal to some length, 0 pixels, awesome, then we're going to come into logic and say condition. So the question we're asking is, if orbit gap is less than or equal to 0 pixels, then we will use the circle. Otherwise, we'll use the orbit. We plug that in there instead. Don't worry, I know the preview's a little wonky. We'll fix that, don't worry. So, yeah. Good. Cool. And I need to wire in the rest of these things. So, like, we've got the orbit gap. We set the primary radius. We need to set the orbit color. And we need to set the orbit stroke. Cool. Like I said, it looks a little funky in the preview. That's because I didn't properly wire up the conditions. That's a bug. It's a known bug. I'm working on it. Okay, so to review, what we essentially have here is a pretty customizable single planet system representation thing. So I'm going to pipe the layer output to here, and this path, we're actually going to just use this orbit, pipe that to the path. You'll see how this works in just a minute. So now we have all these inputs and outputs that exist in this panel on the left, and this is the order that it appears on the node when you bring it into a graph. Now, this is a little haphazard. You could leave it like this if you really want to, or you could, say, rearrange them like that. But I'm actually going to group them up, so I'm going to do orbit. I'm going to say orbit radius goes in here, orbit color, orbit stroke, and orbit gap. Get in there. Cool. Let's add another group for planet. And we'll do planet radius, planet color, and then another group for star. We'll do star style, star radius, star color. Cool. So that's actually our custom node. You can hit export custom node to kind of save it if you find yourself recycling them a lot. Hopefully by the time that this video comes out, I'll fix this bug with the preview, but you know, I can't promise anything. Yeah, so we can just close this out, and there's our star system node. Ta-da! So if I wire this in, it'd be like, doop, and there it is. Let's actually turn that off. Hey. Oh, maybe I have a real bug with this. What's going on there? I think I might have a bug in my switch case. Interesting. Very interesting. I'm not sure what's going on there. I'll get to the bottom of it. I think there's a bug in the condition. Anyways, so for now, yeah, that's very strange. Orbit radius, orbit stroke, cool. Okay, so set an orbit stroke for that. We're going to increase the radius of the planet, and that's fine. That looks good. And now the reason why I wanted to do the path is I can actually now just wire this into a text path. Get this wired into there. And let's change it to Futhark because I like how that looks. Oop. Ta-da! How neat is that? And this is the vertical radio button, by the way. Need to reduce the size of that, and let's change that too. Isn't that neat? Now, I don't know why that orbit gap is behaving so funny. I don't know what's up with that. I'll get to the bottom of that. Anyways, that's kind of how custom nodes work. You can always right-click and edit custom node to come back in and edit it. This is live, so like any changes you do in here will be reflected outside. If you remove an interface node that is connected, it will disconnect wherever there is an instance of it that exists in the world. So be careful. I tried to make it so that you are editing a temporary instance of it, but like it got complicated. So you're editing things live. That's that. So yeah. That's subgraphs. Next up, I'll probably, after I figure out what's going on with this bug that I found here, I'll probably go and create a circle of my own, or a circle from a design that I really like, that I've spotted from a long time ago, from scratch, from the ground up, so that you can kind of get a feel for the process, and I'll talk through it and everything. So stay tuned.